Morning, everybody. How are we breathing this morning? Because I'm really not. The air quality gives me bad headaches and tightness in the chest, and so I'm on my performance-enhancing drugs this morning. My inhaler, right? Yeah, so, oh, it's good stuff. Let's see. What do we got due this weekend? What's due? Chapter 1, Part 1 homework, right? Hopefully you're on Canvas and in Wiley Plus and doing the thing. I haven't gotten any panicked emails yet, so either you're all waiting till Saturday morning or everything's working okay. So hopefully the latter. All right. So what we're going to do today, finish up chapter 1 real quick, give you I need to tell you how I do trig so that you can understand the rest of the course. And then we'll get into chapter 2 and see kind of how far we get. It's going to be a little bit of a speed run of chapter 2 because I really want to get into chapter 3 because chapter 3 is like, it's chapter 2 in 2 dimensions, right? So that'll make more sense when we get there. But like, if you understand chapter 3, you understand it all, okay? So let's talk. I apologize. I'm not a math teacher, so this is going to be bad. Let's, somebody give me an angle. Any angle. 45. 45 is boring. 42 I like. 42 degrees, okay? Give me a number between 0 and 10. 12? Sure. It works for me. Okay? All right. We are going to find... I didn't draw my triangle very well, did I? We're going to find the length of the horizontal and the length of the vertical side of this triangle. How many of you know SOHCAHTOA? Okay, I don't like SOHCAHTOA. I never learned SOHCAHTOA. It was new to me. I got to Fresno City College, and my students were like, Mr. Balogh, just do SOHCAHTOA. Like, the heck is that? Right? So let's do the SOHCAHTOA. I want to do a compare and contrast. Right, the SOHCAHTOA method with, we're going to call it the Balogh method for reasons you'll see here in a second. So if we're going to do, SOHCAHTOA to find that side right there, we got to remember what SOHCAHTOA means, right? Sine is the opposite. So let's see, we need the definitions, right? Sine of the angle is the opposite side over the hypotenuse. Cosine. Adjacent, whatever that is. And then tangent is opposite over adjacent. Okay, so we have to know we got the mnemonic, we have the definitions that the mnemonic tells us, and then I need to figure out whether the arrow is pointing at the opposite or adjacent side. Well, first of all, what's the hypotenuse? 12, right? It's the longest side, okay? So what's the adjacent side? Side touching the angle. So this is the adjacent side right here. And then now that I know I have the hypotenuse and the adjacent, I have to identify which of the functions that's in. It's this one, isn't it? And now that I know that, I have to solve for the adjacent side. So that's adjacent over hypotenuse equals cosine of theta. So the adjacent side is equal to the hypotenuse times the cosine of theta, which means the side I'm looking for is equal to 12, cosine 42, whatever it is, I don't care. Does anybody here know what cognitive load means? This is a idea in psychology that is actually a measurable quantity for how much a brain needs to work to do a task. This is often measured in the context of user interface design, so like working your way through the user interface of your phone, you working in Windows, working in Mac OS. Psychologists and brain function people can study, right? How much cognitive load, how much brain function is required to do a task. Let's talk about Windows for just a second. If you want to shut down your computer, and I understand most people don't shut their computers down anymore, but let's just go through a hypothetical. You want to turn your computer off, okay? What are the steps? What button?
The Windows button.
Okay, in the user interface. Yeah, I know there's a physical button. But in the user interface, if you want to stop using Windows, what do you have to push first? The start button. It's called the start button. Okay? And once you've pushed the start button, now what do you have to push? There's a little symbol down in the corner. No, it's not, because it pops up choices. Choices of sleep, hibernate, shut down. There's probably something else, log out. Okay? And then you can find. So we can measure the cognitive load required to do that, right? In other operating systems, you click one menu, you click shut down, and you're done. Which one has more cognitive load? Windows. Okay, now I know there's shortcut keys and all that kind of stuff. But I'm suggesting to you that the cognitive load of what's on the screen right now is too high. In order to figure out what the length of the side of that triangle was, we had to remember SOHCAHTOA. We had to remember what SOHCAHTOA meant. We had to then do some algebra. We had to identify what side it was. We then had to do some algebra before we could enter it into our calculator and do it. So we could measure like the cognitive load, the number of steps it took, the amount of thought it took, all that kind of stuff. We could measure that. And when I was in college, I was like, I can't do this. Like I've got better things to do with my brain than to do this. Better things like video games. So I developed a method that I have used to this day, and I teach it to all my students, and I have students come back to me after 2 years of being away, and they come up and they give me a big hug, and they said, Mr. Balogh, thank you. I was like, I haven't done anything. And they're like, no, you showed me how to do trig really fast, and it has helped me over and over again. So let me show you how to do trig with the least amount of cognitive load required. Same triangle. Here's the hypotenuse. Here's the side we're looking for. Here's the 42-degree angle. Is the side I'm looking for touching or not touching the angle? It's touching. It's cosine. That's it. That's all there is to it. I call it the touching, not touching rule. That sounds creepy. I call it the Mr. Balogh rule. Okay? Call it whatever you like. I have never seen this in a book. Okay? I'm sure there's a web page for it. I didn't write it. But I can't be the first person that came up with this. And I went into my math teacher's office and I said, look, would you please check to make sure I'm not going to screw my life up if I think about it this way? And at first the math teacher was very defensive. Oh, no, you can't do it that way. You're going to this, that, and theorem and blah, blah, blah. And it's going to go bad. And I was like, really? Can you show me why? And they sat down and started writing a bunch of math down. I'm like, I don't follow. And they just kind of stopped and they looked at it and they kind of, mathematicians when they're trying to figure something out, right? And very slowly my math teacher put his pencil down and he got very quiet. And then a tear started to form on his cheek. And I knew then it was time for me to leave, right? And I very quietly just closed the door and gave him his time. Because he was realizing his entire life was a lie, right? And I just cut through all of this trig crap, right? To a touching, not touching rule. Did you notice what I did? I asked one question. What's the question? Is the side I'm looking for touching or not touching? So this rule does require you to know the hypotenuse and the angle, right? But powerfully, it doesn't matter what the orientation of the triangle is or where the angle is specified. Let's say you have that triangle. That's supposed to be a right angle up there, right? And this is the hypotenuse. Let's call it 15, okay? And you want, and we know that this angle right here is 60 degrees, okay? Sine or cosine for this side? Cosine. How'd you do that so fast? It's touching. if the side you are looking for, this side right here, touches, like the angle is drawn, right? And it touches this side, then all you have to do is write down hypotenuse, cosine, angle, and you are done. That will be the length of the adjacent side.
This only works for angle side?
This works for right triangles. Yeah, no, there's more in physics. Physicists are lazy. We don't like, some physicists like math. They're really weird. Most of us don't like math. We went into physics to be able to do an end run around mathematics and still be able to play with the universe, okay? We're lazy, and so every triangle in physics is a right triangle. And I'm not saying just for physics 2A. I'm like, literally, if we have a weird triangle that's got obtuse angles in it and stuff like that, what are we going to do? We're going to cut it up and make it right triangles, right? Because right triangles are easy, they're fast, right? So that's what we do. Every triangle becomes a right triangle because we can cut up any triangle into a right triangle and be done with it. Okay, so what is the side over here that's not touching the angle? Sine. Okay. What if we had, and we haven't done vectors yet, but what if we had a triangle that, I don't know, looks like this, okay? Where the right angle's right there, and my angle theta is right there. If I wanted to find the horizontal component of this triangle, that's fancy words for this side right here, because it points in along the x direction, right? Do I use sine or cosine? Sine. Why is it sine? Because it's not touching that angle theta. Whatever this hypotenuse is, this will be sine theta, and this will be cosine theta. And now there's a bunch of you that are sitting there going, but wait a minute, x is always cosine. Were you ever taught that? X, to find the x part, it's cosine, and find the y part, it's sine? No? You weren't taught that? Hooray for your math teachers. Because it's not true. Generations of students have come there swearing that if you need to find an x part of a triangle, a horizontal part of a triangle, it's always cosine. Well, it is if the angle is measured from the x-axis. But what if it isn't? So this touching, not touching rule is what I'll be using through the entire class, right? We'll draw a triangle, I'll do something, I'll be like, oh, this side's not touching cosine or sine, right? Basically, we've taken the cognitive load out of this whole SOHCAHTOA thing, and we've distilled it down to the essence of what needs to be identified. Is the side of the triangle you're looking for touching the angle? Then when you're done with all of this garbage, you will just have hypotenuse cosine theta. And if it's not touching the angle, it will be hypotenuse sine theta. That's it. You're welcome. I just taught you an entire semester's worth of math in 4 minutes. It's not true. There's other parts of trig. Did anybody remember all those horrible trig identities? Did you guys have to go through trig identities and stuff like that? Yeah? Most of them are garbage. We in physics, I should not say in physics, in the physical universe, there's only about 4 of them that apply. All the rest are just math puzzles. Most mathematicians are probably screaming at me right now. That's okay. They can yell all they want. Chapter 2. All right. I expected you to look at chapter 2 to find out if, get some of the basic vocabulary down and some of the ideas. Let's see how you did. What is the difference between velocity and acceleration? No, they can both be changing. Okay, so what's velocity? Nope.
Instantaneous speed.
Speed's okay for now. It's movement, but more specifically, it has direction, doesn't it? Okay, so what's my velocity right now? 0. Why is it 0? Because I'm not moving. Okay, what's my acceleration right now? There was less certainty there, right? Okay, because up until this point, your physics bucket of knowledge is kind of mixed together. Velocity and acceleration as sort of being the same-ish thing, but they're not. Acceleration is the change in velocity. My acceleration is 0 right now. Why is my acceleration 0? Some people said because you're not moving. That's the wrong answer, because that's the answer for velocity, right? My velocity is 0 because I'm not moving. Why is my acceleration 0? I'm not changing my velocity, right? My velocity is remaining constant at 0. Okay. One of the superpowers you have in this class is that you get to decide where the center of the universe is. You always knew it was you, right? No? Where's the center of the universe? It's right there. Okay? And why is it right there? Because I said so. You get to pick the origin of coordinates most of the time, right? And it's really, you can't talk about where something is unless you reference it to something else, right? So I'm going to call this 0 right here, okay? And so if this is 0, everything that way is usually called positive, right? Everything that way? Okay, right? So that's like standard Cartesian coordinates, right? Okay, so what direction is my velocity right now? It's positive. Why is it positive? Because I'm going in the positive direction. Which way is my velocity now? It is negative, okay? And I'm coming up on 0. 0's right there. I just passed 0. Okay, what's my velocity now? Still negative. Why is it still negative? Because I was still moving in the negative direction. Good job. Okay, back to, I already forgot where it was. Was it this one? Okay, so what direction is my acceleration? Why? Because it has nothing to do with how I was moving. What was my velocity? It was positive, right? Why was my velocity positive? Because I'm moving in the positive direction. So now my acceleration, why? Because I'm speeding up. Speeding up in the positive direction, right, means that I'm changing my velocity in the same direction I am going, right? What direction is my velocity and acceleration? Velocity was negative. My acceleration was negative. Why was it negative? My velocity was negative, and did it get bigger or smaller? Yeah. Then I did it wrong. I started at 0, and I sped up. So if I go slow, and then I speed up, point with your finger. What direction is my velocity? Okay. What direction is my acceleration? Right? How do you know those are both in the same direction? Because I was speeding up. Right? What mine did we all just step on? You're quiet, you're scared. We all stepped on a mine. What was it? You attached speed up with a positive direction. Can I speed up in a negative direction? Oh yeah. Right? Okay. We're gonna start tossing water out here, right? Bad water. If I start really fast here and I slow down, what direction is my velocity? Positive. I was moving in the positive direction. What direction was my acceleration? Negative. How did you know my acceleration was negative? Because I slowed down. That negative acceleration because it was opposite the direction I was going because I was slowing down. Not because slowing down is always negative acceleration. Let me show you, okay? If I start at 0, I'm going really fast, and I slow down, what direction is my velocity? Negative. But what direction was the acceleration? Positive. Why was I slowing down?
Your acceleration is going
Because my acceleration and my velocity were opposites of each other. So speeding up, acceleration causing a speed up, means what about velocity and acceleration? They're the same. Whatever it is, right? Okay? If velocity and acceleration are in the same direction, you're going to get an increase or a speed up in velocity. How do you get a slowdown in velocity?
opposite direction.
Having the velocity and acceleration be opposites, wherever direction one of them's pointed, the other one's got to be the other way. Okay? So, right now you've gone from a shortcut that's the wrong idea in your brain. It's going to persist because you've had 18 to however many years old you are, right, of thinking that that's the way it is, right? So it's going to take some time, and you're going to make mistakes. You're going to get tripped up in this, right? But as you do that, realize that that's your way of just kind of getting the old water out. We got to get the good water in. And the good water is what? Instead of speeding up, always being positive acceleration, that's the bad water. What should you replace that with? Look at the directions of what the velocity is doing, right? And if it's speeding up, acceleration has to be the same. And if it's slowing down, it has to be what? Opposites. You see what I mean by you come preloaded, right? With some bad ideas in your brain, and we got to get them out. Okay, so let's practice. Quiz. Get your quiz sheets out. Yeah. Oh, wait. Did I not give you quiz sheets? My apologies. Is this really the first time we're doing this? See, I can't. Oh, my gosh. 2B. Okay, because 2B, I did it with the 2B students. Why weren't you guys in 2B class? All right. You guys have no idea how I loved all the blank stares. That was fantastic. That was the exact right look to give me. Like, what are you talking? Everybody take 3. Take 3 of these. You're going to awkwardly have piles meeting in the middle. If you run out because I didn't give you enough, let me know. But everybody take 3. And when the piles get to the middle, send them to the end with the big window. All right, these are how we will record quizzes in here. And I'm going to explain to you how to use them. Take 3, yeah. Thank you. All right, did anybody in the middle? Yeah, we got, okay. This is what happens when you don't count. Is it back here we ran out? Did we run out in the middle? Anywhere? What do we need? You need 2. 2, 3. You need some? We got enough over here? Anybody else missing out? You got extras? Okay, I'll come back and get those. All right, does anybody feel left out? Anybody want to drop? All right, don't ask those questions, Mr. Bala. All right. So, notice, how many quizzes are we going to do? Up on the screen. There's 2, right? There's 2 questions up there, 2.1 and 2.2. My demonstration here is not going to have the right numbers on it, but you're going to write down quiz number 2.2, like in that first sort of row. Quiz 2.2, did anybody catch how many points there were? It was 2 points, right? And then in the next box down, you're just sort of setting it up, right? You're going to write 2.2, because it's chapter 2, question number 2, and you're going to do out of 2 points, okay? So it should be blank. There should be no answers in it. You're just writing in, 2.2, 2.1, 2.2, and we know they're out of 2 points. And that's what I'll do. I'll say, okay, it's time to do a quiz. You're going to get your quiz sheet. You're going to write 2.1, whatever the numbers are, and then whatever points are available on the quiz sheet. And then you'll be ready to answer the question. Now, the reason that there are two questions is because there's actually only one. You're going to get the same question twice. But the difference between them is the first question you're going to do by yourself. All on your own, not talking to each other, trying not to give each other dirty looks or that look of haunted, I'm dead, right? You're just going to do it yourself. Why would I want you to do it yourself? I want you to have an opportunity, right? To see if, like, what's in your brain. Give you an idea personally of where you're at. If you're staring at the question, it's like a total blank and you're freaking out. It's not good, but it's not bad either. Like, you know something now. You know that you don't understand, like, the question or what's been talked about, right? But if you're able to get some traction in it, right? How many of you ever sat in a class and you're like listening and you're actually there and you're listening and the teacher asks a question, you're like, wait, I got that, give me. And then the person next to you blurts out the answer. What happens to your train of thought? Utter derail, right? Physically, what has not happened in your brain is a neural pathway was not formed between the idea and its conclusion. By hearing the answer, your brain was robbed of an opportunity to form connections between neurons that your brain can traverse again and again and again to develop a memory. And so I want to give your brain an opportunity to try and form that pathway. It won't work, it won't happen every time, that's okay. We've got other tricks, okay? But let's just give everybody a chance. It's timed, it's going to feel fast, okay? But that's okay. I'll talk about why that's okay at the end, okay? So you're going to have a chance to do a question by yourself. The second quiz, the second problem, is the same question, but you're going to be able to talk to each other. So once I call time, there you cannot change your first answer in that box. In the box, you need to put the answer down. It could be multiple guess, whatever it is, right? You put an answer in the box and then a reason. This is a terrible reason, by the way, okay? Some physics reason, whatever, right? After you talk with people around you, and in talking with people around you, what are you going to be doing? How are you learning? Because you're teaching each other, right? You're trying to explain to somebody else what was in your brain. It could be, there's nothing in my brain, please help me. It could be, this is how I did it, right? But you should be talking about why. Like, what is it that you did and why did you do it that way? If you want to change your individual answer, there's a piece of information you didn't consider, you got convinced by the people around you, whatever, then write the new answer down in the second box. This technically is like a group answer, but it's not the group's answer. You do not have to change your answer, right? You do not have to agree with the people around you. The second box really just reflects updated information and updated answer after you've been able to collaborate with other people and teach and learn from them. Okay? The whole point of this process is for you to be teaching each other. That's really it. Okay? And to find out whether or not you know something. Write the updates in there. This is technobabble from AI. So if the answer is the same, like if you're not changing your answer, do not rewrite your answer, okay? Just either say same answer, right? Or just draw an arrow that like connects the two boxes. When I look at it, I'll go, oh, okay, they're just saying it's the same. I don't want this to be busy work, right? Okay, so not changing your answer, you're just going to draw an arrow down. Okay, so what we're going to do right now, and I haven't talked about how we're going to grade it. We'll do that in a second. Let's do this, right? I'm going to throw a question up on the screen. I want you to take a couple minutes, think about it, pick an answer, write it down in the first box. Just for clarity, right? You are giving directions for displacement, velocity, and acceleration. So like, it's multiple guess, but there's 3 answers there, right? Several of you need to silence your devices. Go ahead, keep writing as I talk here for just a second. You could be drawing a picture. You could just be putting down A, B, C, or D. One of these is correct. But more than the answer, you need to have something there that's like, why are you picking that choice? So again, if you're drawing a picture, maybe the picture is the justification. Maybe you're writing down in words what's going on. Maybe you've got some math way you want to figure it out. Just have some way of justifying it. And if you are guessing, because you're just totally lost and not getting it, just say, I guessed, right? Sometimes on these multiple guess kinds of things, I have students, well, Mr. Balogh, I know the answer is this because it's like by definition, that's what it has to be. So I'm like, okay, tell me why the others are wrong, right? You can justify a correct answer by pointing out the flaws in all of the others. So there's lots of different ways to go about doing this, and you'll find a way that works for you. At this point, you should have A, B, C, or D indicated in that first box with some sort of reason for why you are picking that. Again, it feels fast sometimes, right? And that's by design. Okay, what I want you to do now is not change any of your individual answer. That's going to be set in stone. I want you to turn to the people around you, introduce yourself if you don't know them, and tell them what you picked and why. Go. Is this too bright? Is it making it hard to see? Is it okay, or should I lower the shade? You see it okay? All right. All right. It's hard to remember to do this, but at some point you should write down an answer in the second box, right? Okay. I'm reminding you now, and I'll kind of remind you for the first few quizzes we do, but eventually I'll forget to remind you. But like as you're discussing, as you're realizing, oh, I didn't think, right, or whatever, be updating the answer and like put down like why you changed your answer. Like try to identify maybe where you went wrong. If you're not changing your answer, what are you doing? Just write an arrow or write same, right? Okay, just indicate real quick that you're not changing your answer. So let's talk about grading this. We should talk about what the correct answer is, but then we'll talk about what grading is. Let's see. Let's vote on it. Everybody knows that science is all about voting, right? You need to maintain the illusion of democracy. Okay, so how many of you say the answer is A? Okay, few of you. How many of you say the answer is B? No takers? Just a couple. Okay, right? Yeah. Strong and wrong, right? Okay. C? Oh, we hit a nerve. D? Okay, C was the majority. Somebody from C, defend your position.
So I want to be completely frank, not a clue on displacement.
Yeah.
But the reason I chose C, or it was between A and C, the reason I chose C, it's moving in the positive direction, so velocity is positive.
So velocity is the middle one, right?
Yeah.
Okay, so if we ignore the first signs and we just sort of look down, right? If it's moving to the right, okay, then we know the velocity has to be positive, right? So you eliminated B and D just on the velocity direction alone, right? Okay, may I ask, this might embarrass you a little bit, why are you clueless on displacement?
I don't even know if it registered in my brain you talked about it.
Right, okay, I didn't. Why didn't I? Because you're supposed to read about it, right? That should have been something that you pick up on. Let's real quick, what's displacement? If this is 0 and I'm over here, is my displacement positive or negative? Positive. Okay, and if I'm over here? Negative. Now, here's a bad piece of water, right? If I go 1 meter this way and then 3 meters this way, what's my displacement? -2. I was 0, I went +1, and then I went -3, but displacement's always measured from where you start. So I'm -2 from where I started, right? But what was my distance traveled? 4. That's the difference between distance and displacement. But again, kind of expected you to get that from the reading. And if you either didn't do the reading or you're like, I don't remember any of that, I'm trying to help you understand sort of the level. Okay, yes, you may have read the word in the vocabulary at the end of the section, right, of the summary, but make sure that you kind of dig in just a little bit to see if you really kind of grab onto that definition. Okay, but anyway, back to your explanation. That's fantastic. So we're between A and C, right? So, I'm sorry, would you pick C?
I did.
Yeah, so why did you pick C?
So then going into acceleration.
Looking at the last signs.
Yes, which is the third one.
Yeah.
We're going in the positive direction, and we're still going in the positive direction, but we're just slowing down. So that would be a negative acceleration.
It's because slowing down, we just learned, slowing down means that the velocity and acceleration are opposites of each other, right? And so if velocity is positive, we said it was, then the acceleration has to be, and therefore C. I like it. C is the correct answer. Okay? So those of you that got C, fantastic. Pat yourself on the back. Write down a note that says, you know what, I got that, but I should make sure that I continue to get it, because you're going to leave this room and what's going to happen? You're going to forget. You're going to snap back to that, well, acceleration just means speeding up, right? Which is not the right answer, okay? Right? And so be forgiving to yourself. If you screw it up again, it's okay. You're going to screw it up, but keep learning, right? Keep trying to get that correct, that good water flowing in your brain. If you didn't get it, right? If you didn't pick C, then you want to be asking questions like, well, why? Like, where did I go wrong? Was it listening to the people around me? Maybe I need to move. No. Right? But like, do some analysis about like kind of where you tripped up. And if you can't figure it out, email me. Come see me in Grass. Mr. Balogh, I messed up the quiz. I don't know why. And I'll start trying to pick at your brain and see if we can't figure out where it went wrong and help you overcome it and all that kind of stuff, right? So now, grading this. Who grades this? You do. You're like, sweet. 50 out of 50. Do the points matter? No, they don't. Points are an illusion, okay? Points are on there because students will ignore it if there's no points, right? Okay. The truth of the matter is that I think you need, let's see, last semester I screwed this up a little bit. I think you need 30 points overall on quizzes, and I handed out like 150 points over the course of the semester. What does that tell you?
Don't be afraid to fail.
Don't be afraid to fail. You have plenty of opportunity to get to your 30 points. And when you get to your 30 points, there's no like extra credit or anything. You just get your 30 points. And once you get 30 points, you have an A. 5% of your grade's an A. So how are you going to get your 30 points? Plus 30 on my quiz right now. If you're here and you screw up every single one of the individual quizzes, where are you going to get your 30 points? By talking with each other, right? Okay? There's going to be days where you get the individual. There'll be other days where you and your group both died. These quizzes are designed to target what we call misconceptions in physics. There's specific things we know, like this whole acceleration velocity thing, that people have wrong in their brains. And they bring these misconceptions with them. And we have to like work to get them out, okay? And so you might say that they're tricky, or Mr. Bailey, you fooled us. I did it on purpose because I'm trying to jumpstart your brain and help it realize where a piece of information might be flawed. So you're going to be failing a lot on quizzes, but it's okay. If you're here and you're taking part, you're going to get your 30 points by the middle of the semester. And even then, you're not even going to realize it. And that's just when a quiz comes along, you're going to be like, oh, okay, I can find out if I know this. That's what this is for, right? If you are missing a class every week, it's going to be harder, right, to get those 30 points. At the end of the semester, I'll collect these, and I'll look at them, okay? And I'll see whether or not the 30 points is justified, right? If there's evidence that you were here and you were taking part, okay? But that doesn't happen until the end of the semester. Do your best to hang on to these, keep track of them. Don't panic if you lose them or they get stolen or whatever. Just contact me and we'll work it out, okay? All right, so you grade yourself, right? And, you know, be honest. If you messed it up, 0. If you got kind of halfway there, give yourself a 1, right? You're feeling bad about yourself today, need that little pick-me-up, still got it wrong, 1. Okay, that quiz was recorded like on the YouTube, but from here on out, I'll be hitting pause on whenever we do a quiz, right? So it's there for you to go back and kind of see how the flow was. I'll coach you through it a few more times, and then it'll become natural at that point. Oh my gosh. Okay, so problem solving. There's actually only one problem in this entire class, okay? And the content of the problems will change, like kinematics right now, Newton's laws later, energy, momentum. The individual details will change, but really, there's only ever one problem to solve. And that problem is the problem-solving method. What are you here to learn?
Physics.
Nope.
The secrets of the universe.
Nah.
Problem solving.
It's kind of weird for me to tell you that you're in a physics class not to learn physics. That's a side effect. Learning physics is important in your future careers, but it's not as important as the thing you are here to learn.
Critical thinking.
How to think. Not how to think, that's wrong. How to learn. When I talk to doctors and managers of physical therapists' office and architects and people who are in charge of employing you in the future, I always ask them, what do I need to do to get these students prepared, right? So that when you're looking at them and trying to hire them, what is it you want? Over and over again, they say it a bunch of different ways, but they're all saying the same thing. We need them to know how to learn. Sometimes they say things like we need them to know how to write an email and talk on the phone. But mostly it's we need them to know how to learn, because we're going to teach them the things that they need to know, right? It's not like you need to come out of college knowing stuff. You need to come out of college knowing how to learn and be self-motivated to learn, right? Rather than having your hand held the entire time. So that's what you're here to learn. You're here to learn how to learn Specifically in physics classes, STEM classes, you're here to learn how to problem solve, to have a systematic method for conquering anything. Because let's face it, as soon as I throw a problem up on the screen, what are you going to want to do?
Ask for help.
You're going to want to run home, jump in your bed, assume the fetal position, throw the covers over your head, and make sure that the universe goes away, right? That's what you want to do. You're going to try to problem solve, right? Okay? But the first reaction is, I don't want to do this. The problem-solving method is how you conquer it, right? A systematic, a step-by-step approach to conquering anything. I use this method whether it's physics or taxes, right? It all starts at the same place. I can't remember more than 3 things at a time. And so I'm pushing the boundaries with a 4-step process, right? I have seen this process outlined in textbooks and videos and things, and I've seen problem-solving processes that have like 17 steps in it. Way overkill, okay? There's 4 things we need to do. We need to visualize, we need to strategize, we need to do it, and then we need to check it. There is a reflex in this class that you are all going to have, and you'll tell me about it constantly. When I throw problems up or you look at problems in your homework, as a noob, you are going to want to start with the math. You're going to want to start with a formula. And after a while, you're going to be saying things, well, Mr. Balogh, just tell me which formula to use. Because, quite frankly, the math is the easiest thing, right? Physics is the hard part. But the physics takes place in the first 2 steps, and it's the first 2 steps that I focus on and I will help you with. The do it step, the part where we actually are going to do some algebra and some trig and whatever, I'm going to blitz those. That's a speed run because this is not a math class. It's a physics class, right? I need to model for you and help you understand how to visualize, how to strategize, and then you can do the math, and then we can go back and check it. Visualization is an organizational step. It's like coming to grips with what you know and what you don't know. Maybe drawing a picture, trying to organize the concepts and ideas, okay, that are involved in the problem. Strategize is coming with a plan. What are you going to do? Like, where are you? What do you have? Where do you need to be? And sort of a loose idea of how you're going to get from between those 2 points. Once you have that strategy or that plan down, that's when you just crank the math. And then finally you go back and make sure that your answer makes sense. I used to be a climber, a mountain climber, and I would teach people how to climb. And a new person to climbing, because they're kind of scared, you're up on the wall, you're up on the rock, right? The fear of falling, whatever. They will concentrate on the wrong thing, okay? They'll concentrate on not falling, okay? You're always going to fall when you're climbing, okay? The key is to have a rope. What's the rope for? It's to keep you from hitting the ground. Who's responsible for whether or not you fall?
Your belay partner?
No, you. You're responsible for whether or not you fall. But a person that starts with climbing will often try to mimic what another climber has done. This is true for all like skills, right? When you're first new at it, like if I went and climbed on the wall and I said, okay, now you do it, chances are you would just try to do exactly what I did, right? You'd be sitting there trying to memorize where the foot good and the hand went and all that kind of stuff. And you're skipping the why. Why did Mr. Balogh put his foot where he did? Why did Mr. Balogh shift his rear end over to the other side? Why did he put his, right? There's a difference between just trying to kind of mimic what's going on and then taking a step back and asking, well, what is the reason that that happened? It's the difference between what we call novice thinking and expertise thinking. You can have expertise thinking without being an expert. You can be totally new at something, but approach it, right, with the attitude of an expert. expert, what's the difference between a professional and a not professional, or like an expert and a novice? What's the definition of a professional? Someone who has already made all the mistakes. Right? That's what separates an expert from a novice, right? Experts know the mistakes to make and avoid them, right? So you're not going to be able to avoid mistakes because you're still novices, but that doesn't mean you can't think with that expertise thinking of, why am I doing it this way? Not just, oh, we used that equation last time, let's just use it again, because that might mess you up, right? But why am I picking this equation? How is it going to help me, right? Taking that step back. That's the important part. You master that, your homework's going to go faster, this class is going to be easier. If you want to live in the trenches of what equation do I use now, you're going to be forever lost and this class is going to be hard. So try to not shortcut the first two steps. So let's do an example of chapter 2 stuff and all of this stuff. Okay, I need to write something on the board because, like all good things happening, there is a toolbox. In chapter 2, how many equations were there in chapter 2? Like formulas in the chapter. Did anybody look at it? Is there 4? Kind of in the summary, right? If you actually look at the chapter, there's more. Do you guys promise here and now that you will not shut your brains off if I put math on the board? Just you've been programmed. As soon as your math teacher starts talking or you see math, just be present, stick with me. Oh, shoot, I forgot to check. Are those the symbols your book uses? Or the ones that are in my head? Yeah? Yes. Okay. What does that say? Remember, math is a compressed language for ideas. What's this? The final velocity. What's this one? The initial velocity. The velocity it starts with versus the velocity it ends with, right? What's this? Acceleration. What's this? Time. This equation says that the velocity you end up with is going to happen or come about based on the velocity you start with and how that velocity changes with time. That was a really long sentence, wasn't it? But do you see how that idea is encapsulated in a very short statement? This is a tool. And like any screwdriver or hammer, you use it for a specific thing. You're not going to use a screwdriver to hammer nails. You can if you want, but you're going to get hurt and it's not going to work. This one. We've introduced a new symbol. What's this delta x over here? It's displacement. It's how far something goes. Whenever you see a delta, it's final minus initial. Does your book just uses x. Sorry. We'll get to deltas later. Okay. All right. And then the third one. Just x. They're assuming that you're going to put 0 where the thing starts, which we'll change that later. Okay, so I call this the toolbox for this chapter. There's like a fourth equation that they give you and some other equations that are in there. You don't need them. This is all you need because these will solve every problem, okay? However, like any good toolbox, you need to know how to use the tools, right? And the tools themselves are telling you. What is missing in this third one? Time. So if it's not asking you for time and it didn't tell you what the time is this a good candidate? Right? Okay. This one's missing time. What's this one missing? The final velocity. What's this one missing? Displacement, right? These are clues as to what these tools can be used for, right? And then no, it's like, Mr. Bailey, you're starting with the equations. This is the toolbox, but now we have to build the house, right? The toolbox does not know how to build the house. Who knows how to build the house? The general contractor, right? The general contractor needs a plan, needs people to work, needs materials, and some tools. These are just one part of the whole structure. What just happened to your brain? Yeah, right? Ah! This class is nothing but word problems. You're welcome. So, get in here. See? See? The door. Oh. Well, I got 2 for 1. Everybody, our Dean McManus in red, okay? And Miss Jones, a math teacher. I don't know why they're here, but... Oh, you teach right out? You teach after me? Like... She needs to move to a different room. Oh, yeah. So, yes. No, you can interrupt any time. I don't mind interrupting. I have to be really careful with my math jokes now. Yeah, but do your thing over there. All right, so I've given you a problem, right? And now you're in a panic mode because it's a word problem, right? But what are we going to do first? What's the first step in the problem-solving process? Visualize it, right? So, can you put yourself into a situation where you're traveling in a car at 60 miles an hour? Can you see yourself? No, because you've never done it before. Okay. Can you draw a picture? Maybe, but Mr. Balogh, I'm in this class, I'm in STEM, I don't want to draw pictures, right? I'm not an artist. Okay. Can we make a list of what we know and what we don't know? Mm-hmm. Tiffany, this board is an abomination, by the way. The reflections, the color behind it, like it's really bad. So, Shirley, can you, what's that? It doesn't matter. That just takes the reflections out. The contrast is really bad. Can you get her some of those pens that are more of like the, yeah, they work a little bit better. No, I don't use it very often. Sorry, ignore us while we talk shop. All right, so let's make a list of what we know and what we don't know. What do we know? 3.1 S, what is that? That's seconds, that means time. As a matter of fact, I'm going to go one step better, and I'm going to show you a list of all the things we could possibly know or not know. Where am I going to get my list of things I could possibly know or not know? Toolbox, right? I can look at my tools, and this is the list of everything I can know or not know. So let's make a list. V equals V naught equals A equals T. Where'd those 4 come from? The first equation, right? Okay. Second equation, I pick up an X, don't I? But are there any new things? Nope. What about the third equation? Anything new? No. For this toolbox, for this chapter, this is the total amount of things you could know or not know. So, do we know how fast the car is going at the end of its motion? No. Yeah, we do. And unfortunately, it requires reading comprehension. Complete stop. Sometimes you have to read between the lines, right? What does complete stop mean? 0. Do we know how fast the car is going at the start of its motion? 30 miles. Would you explain the mistake you just made?
I cannot read.
Okay, I can't read, right? I thought so he said 3.1, right? Because he just went for the first number on the line, right? How do we know that this is the speed? The meters per second, right? The unit that is on it. Again, that's something I expect you to get from the book, okay? But we know that that's the initial because it says it's traveling at that speed before it begins to slow down. Do we know what the acceleration is?
3.1 seconds.
Nope, that's not an acceleration because seconds is a unit of time. This is great. I love that you're shouting it out and making mistakes. This is fantastic. Keep doing that, right? Because whoever shouted out over here, there's about 10 people over here that went, oh yeah, no, that's not it, right? We all need that. It's fantastic. Strong and wrong. What?
Acceleration is negative. That is all we know.
Oh, you're going ahead. Why did you say the acceleration was negative?
Because it says it's
It's slowing down, right? So we're not going to put a negative sign on the acceleration because we don't know what it is, but is that a possible check when we're done? Ooh, power. Okay. So do they tell us what the acceleration is? No. So what I do is I don't leave it blank, I put a question mark. Because what that tells me, future me is going to come back and look at this and wonder what happened. The question mark says, I thought about it, I think it's not given, or I don't know what it is, so I'm indicating that I just, at this present moment in time, I didn't. If I just leave it blank, I don't know if I missed it or whatever, right? So I'm trying to indicate that I don't know. Do we know the time that elapsed? 3.1 seconds, okay? Do we know how far the car went? No. Okay? All right. That's like a way of visualizing. It'll change for Newton's laws. It'll change for energy. There'll be different methods that I can tips and tricks and hacks that I can show you, right? But in general, you want a way of organizing information. And I'll demonstrate some other ways of doing this in this chapter. But a list is a good place. Like my brain goes to the list because I can't draw worth a darn. Okay? But if you want to draw a little picture of car moving, whatever, attach your numbers to that. It doesn't matter. Okay? Just come up with a way of organizing what you know and what you don't know. Okay, strategize. What the heck are they asking us to do? Part A, find the acceleration, right? So I'm going to come in and I'm going to circle the thing that I am looking for. At some point, I know I am going to get lost. I'm going to go into an algebra jungle and I might not come out again. And I just need a direction, right? I'm going to look around on my work and I'm going to go, wait, what am I doing? Having circled the thing I'm looking for has saved me over and over again, right? Like it's just, oh yeah, that's what I was doing, right? Okay, so just kind of indicate kind of what you're after, okay? So we know where we want to be. We know where we're started. How do we get there? Is there a tool that can get us from V, V naught, and T to A? Yes. Which one is it? Why is it the first one?
Because it has all of those variables.
Because it has all of those things in it and critically doesn't have the other unknown in it, right? Okay? Did you see that? Did we do any math so far? We have done zero math, right? We've been looking at some equations, but we haven't done any math. But now we have an idea, a plan, don't we? For the first and last time in this course, I am going to model the correct behavior, but from here on out, I'm not going to do this anymore. I'm going to write down the plan. Okay? As follows. Use the first equation and solve for A. As noobs, I strongly suggest you write down your plan. There will come a time in this course where you won't have to do that. You'll have the skills down and you'll be able to hold it in your head and you'll be able to rip it off and you'll be great. But at the start, how much would future you appreciate knowing what you were attempting to do? Right? It can be hard to piece out if you're just looking at some math. How many times have you sat there looking at your math going, what was I trying to do? Right? If you leave a little note at the top, this is what I'm trying to do, and then do it, it's going to save you time as you study this stuff, right? Now, this is the last time I'm going to write these down on the screen. I will verbalize them, but my handwriting is very poor, and it takes me too long to do it, and I just, a little pieces of my soul die when I have to write something down. So I'm just going to verbalize it after this, right? But I really, really strongly suggest that you write down your plan, write down your strategy, even if it's wrong, right? At least you can refer back to it and go, okay, that was the wrong way. I don't want to do it that way again. So now that we have visualized, organized our information, and we've strategized and come up with a plan, what are we going to do? We're going to do it, right? Now we have to do math. Critically, we have to write the first equation down correctly. Do you want to know how often I screw that up? A lot. Okay. And now we got to do some math. There, I did some math. Okay. That was probably too fast for you. I did about 4 steps in one line, which is dangerous. Okay. But I'm a professional driver on a closed course. Do not attempt. Do whatever it is you need to do the math right. But this is not a math class. I tend to blitz this section really fast. Right? I subtracted V naught from both sides, and then I divided by T to get that A. Okay? Notice I did it in symbols. You're going to want to put numbers in and do algebra with numbers, which is fine. Okay? You will save time in the long run if you do it by symbols first. You'll have to trust me on that one for now, but the more you practice symbolic manipulation of your stuff, the better you'll get at it, and the easier the troubleshooting will become. When you've got that red box and you're trying to prove the computer wrong, it can be really hard to be able to see, because numbers will hide relationships between things. And if you maintain those relationships as you go through, you can catch sometimes pretty quick, oh, I did the wrong T there or something, right? So symbolic representation is more powerful. But now I can throw in some numbers. 0 minus 27 all over 3.1. You can put units in to check the units, right? This is a meter per second divided by a second. So what unit are we going to come out in? Meters per second squared. And does anybody have a calculator? Because I failed to open my notes on this. 8.7? Sure. Okay. Negative 8.7 meters per second squared. Do the units check out? Is that the unit of acceleration? Yes. Yes. What's the other? Okay, so what are we checking? Units.
Sign.
Oh, the sign. You should interrogate every answer. And you should be asking questions like, why are you positive? Why are you negative? What does that mean? What does a negative sign on this acceleration mean? It was slowing down. Is that true for this problem? I agree with the sign. Okay. As for the actual number, there's different ways you can kind of figure out whether or not. We tend to go, in physics, we tend to go for what's called order of magnitude arguments. So, for example, the car is going about 30 meters per second, right? Just kind of rounding off a little bit. And it's going to take about 3 seconds to stop. So if it's 30 here, and 3 seconds later it needs to be 0, then how fast does it need to be going, like in the first second? 30 to 20, the next second, 10 to, so is 10, negative 10, about 8.7? Yeah, that seems reasonable. I've checked my answer. Other people say, well, put the answer back in and see if you get the same number. That never worked for me. Garbage in equals garbage out. I can make the same mistake in the mirror universe on my way back through the math as I made on the way through and prove that myself is still wrong, right? So there's different ways to check it. Quite honestly, a lot of your checking in this class is going to be putting into the box to see if it turns green or red, right? Which is a bad skill to teach you, but it is what it is. Because you're not going to get any colors on the exam, right? Your exam paper is not going to light up and go green, right? So you're going to want some ways to be able to check your answer while you're in the heat of the exam, right? And be sure that that's the answer. And that way cannot include, right? Or checking your phone. Okay, so we did part A. See how I boxed my answer? Just say this is where I got for part A. All right, part B. What do they want to know now? Now they want to know X, right? Do I need to reinvent the wheel here? Do I need to come up with a new list? No, I can come up here now and just put in negative 8.7 meters per second squared, right? And so what I want you to do right now is turn to each other and strategize. What tool are you going to use and why? Go. All right, what'd you come up with? Use the second one? Who said use the third one? Anybody? Yeah? Does the third one work?
A lot of extra steps.
It does work, but it requires algebra, doesn't it? This one, it's already solved for me, right? Physicists are lazy. I picked number 2. The third one definitely works and gives you an insight as to how to check the answer, right? You can do the second one, get an answer, but since the third one also works and is independent of this one, you could do the third one, and if you get the same number out, guess what? So, what's the plan? Use the second equation. Solve it for x. Done. X equals v naught t plus 1/2 at squared. 27 times 3.1 plus 1/2 times a negative 8.7 times 3.1 squared. What just happened to all my units? I got rid of them. Why? Because they confuse me. When I just, if I'm putting numbers together and I see letters in there, I just get confused. Here's a trick. This is a v naught t. You know how bad my handwriting is? My t and my plus became the same thing. Sorry. Somebody should have said something. Fair. But you see, even experts make mistakes, right? And I just didn't catch it because in my brain, isn't this and this the same symbol? It is in my brain. You guys don't know this yet, but I have dyslexia. And so it's a problem. Symbols are a problem for me, and those two, to me, look the same. I have to be really careful. So, yeah, catch me. Catch me on, like, if you're just not certain about what's going on and things look weird and whatever, it's not you, it's me. Okay? And throw your hand up, say something. Sorry about that. Okay, back to the units. Why didn't I put the units in? Well, so here's a way to kind of fly close to the sun, be a little bit dangerous, but get it right. If you always use the standard SI unit for the velocity and for the time and for the acceleration and for the distance, you are guaranteed to get the correct unit out of these equations. These tools are dimensionally consistent. What we mean is they know that velocity should be in meters per second, that time should be in seconds. What should distance be in? Meters. So if you're given a velocity in kilometers per hour, what should you do with it? Convert it to meters per second. If you're given an acceleration in feet per hour squared, please no, convert it into meters per second squared. Convert every number you get that is not standard. It needs to be a meter, a second, or a meter per second squared. Meters per second, right? It has to be that. Then you are guaranteed to get the correct unit out. Like if you're solving for distance, you'll get a meter.
So final velocity is meter.
Yeah? Well, it's 0, so it'll just kind of wipe everything out anyway. Yeah. Yeah, velocities are always meters per second. Sorry, meters per second. Velocities are always meters per second. Distances are always meters. Time is always in seconds. So on and so forth. Standard units in equals standard units out. I'll say it a lot. Okay. What is this number? Is it 41.9? So 42? It's a good number. How do we check it? Do the other equation. This one's harder to do in your head and like do a conceptual thing for. So if we check it with the third equation, and I'm solving this for x, that's going to be v squared minus v naught squared over 2a equals x, and sure enough, when I put that in, I'll get something close to 41.9. Like there might be a little bit of round off error here and there, right? But it'll be within reason, right? And can be a quick check to make sure that we got it right. What did I teach you today? A method, right? Did I teach you any physics? Yes. Remember the whole acceleration, velocity, direction thing? Okay, so that was physics, right? This is physics, but more importantly, I taught you a method. My challenge to you is work the method. Learn the method, right? Try to not be down in the weeds thinking about which equation do I use. Start big. Make these lists of what you know and what you don't know. Try to develop a plan. As you exercise that muscle, which will be hard at the beginning, which will feel slow at the beginning, you will pick up pace and then you will start devouring physics problems like you wouldn't believe. If you constantly stay in the weeds, it's not going to work. Homework is due this Saturday, right? I'll see you in grass tomorrow if you need any help with that. 3-day weekend. Sorry for the homework assignment, but it couldn't be avoided. If I don't see you tomorrow, I will see you on Tuesday.
I always wait till the professor starts talking.